Kayla.
And Jim.
And welcome back to another Meteorology Monday. Today, we answer the age-old question of, oh my goodness, it's below freezing outside, yet it's raining, but it's not snowing, but it's not sleeting, but it's raining, and it's like, what is happening? I don't understand. Today, we're going to talk about why that can happen, how it happens, and we're going to throw in some Skew-T log P diagrams.
Oh no.
Before we get into today's topic, make sure that you hit that like button and subscribe down below so you never miss another Meteorology Monday. How can we have a temperature where, you stick your thermometer out the window and it says 28 degrees, but it's also raining at the same time?
And there's the flip side to that. It could be 37 degrees and snowfall.
And snowing, yeah.
So, really what it boils down to is the vertical profile of the atmosphere.
So normally, as you go higher in the atmosphere, the colder it gets, because you're going towards space, and space is pretty cold. So the higher you get up in the atmosphere, normally the colder it gets. But sometimes we have what's called an inversion layer, or a warm nose. And we see this on a Skew-T log P diagram.
Usually that inversion layer, it depends on the weather situation. If you've got clear skies at night and it was a bright sunny day, it's pretty warm at the ground, so then overnight as it cools, that warm air starts lifting up, and it could be a couple hundred feet off the ground, 1,000 feet off the ground. It just depends on where it is. There's other situations in which you've got a low-level jet, say around 5,000 feet. As meteorologists, we call it the 850 millibar jet, and it comes in out of the south or southwest, and it brings in warmer air over top of cooler air.
Because warm air rises.
That's right. So if it's cool at the surface and then you go up, you'd encounter warmer air because that jet is bringing warmer air in. So, there's a lot of different situations that's set up for this. So we have 4 types of winter precipitation.
Yep.
We have the rain, we have freezing rain, we have sleet, and we have snow. So we'll start with the warm side of the spectrum first and work our way colder. So the warm side of the spectrum is where your temperature profile from the surface on up quite a bit, X thousand feet up, 10,000 feet up, it is warmer than freezing that whole way. So the water droplet remains water all the way from there all the way down to the surface, and it's rain.
It's
Very
water
simple.
in cloud, it's water at ground.
That's right.
Rain.
Simple.
So let's talk about the situation of freezing rain, which is where we have on the ground very cold temperatures, but it's raining, and you get freezing rain where this super cooled liquid hits the ground and it either freezes on contact, or if the ground is still warm, it stays rain. And this happens because of one of those warmer layers. And so on a Skew-T diagram, which is what we call a fancy diagram that shows the levels of the atmosphere and also the temperature profiles and also the adiabatic yada yada
Yada yada.
It has a couple lines on it in the squiggle, and they tell you if it's going to snow or sleet or freezing rain.
You need to be a meteorologist to interpret the squiggles.
So for the freezing rain profile, we have what's called a warm nose, which is where it's below freezing on the ground, but as you go up in the atmosphere, it actually goes above freezing for quite a substantial amount of time, and then it goes back to freezing. So you have this precipitation falling, it's falling as snow, and then it hits that warm layer and it gets really hot and it ends up melting and turning into rain. But then as it travels down and it gets closer to the ground, it's now below freezing again on the surface, but it hasn't had enough time to refreeze, so it's still just rain.
So at this point, it's super cold at this point,
Super
and
cold.
so it'll be liquid, and then once it hits a surface that's below freezing, it freezes upon contact.
Yep.
And
So like your car, your grill, or
That's right.
bushes outside.
Metal surfaces, elevated bridges, those kind of things that tend to cool down very fast and stay cold, those kind of surfaces get it first.
Yeah, that's why those fancy signs are like bridge ices before road.
That's right.
That's this situation.
That's right, exactly. And part of that is because you have natural heat coming from the ground, so that when you have a bridge, you've got air underneath it, so that's why the bridge...
Heat.
That's right, that's why the bridge winds up freezing first. So now, the next thing is going from a little bit colder, from freezing rain, into sleet.
A little bit colder. So with sleet, we still have that warm nose effect because you have your water droplets falling, it's snow, and then it hits that little inversion layer, that warm nose, and it melts, but then it gets really cold at the ground again far enough up that the now melted water has time to refreeze. But it doesn't turn back into snow because it's already like melted and it's a droplet and then just like refreezes. So this becomes sleet. So it hits the ground as ice pellets instead of snow or rain.
That's right. So the thickness of the cold air, there's basically none when there's rain. Cold air meaning freezing or below.
Yeah,
or below freezing. We'll call it below freezing. So there's nothing for rain, and then you've got a good little bit of a depth there, maybe a couple hundred meters, a couple hundred feet, something like that, for freezing rain to occur. And then that cold layer is thicker, and that's where the snow turns to rain, and then refreezes, becomes sleet. It's got enough time to refreeze and hit the ground because that cold layer is a little thicker.
And then that brings us to our last one,
That's
which is snow. So, I mean, we've got the warmest, we've got rain, we've got our two middle ones. So, obviously the one on the side is just gonna be the opposite of rain, right?
That's right.
So, what's the snow profile look like?
So the snow profile has no warm nose at all. And when we talk warm nose, we're talking about any temperature, in the lower, few thousand feet where it exceeds freezing. But no, the whole profile is below freezing.
Yep.
So therefore the snowflake remains a snowflake all the way down.
It's snowflake in cloud, it's snowflake on ground.
That's it. Exactly. So you may be wondering, why do we call it a warm nose and why it's a Skew-T diagram? Well, first of all, let's talk about the Skew-T diagram. It's actually short for Skew-T log P, or a skewed temperature logarithmic pressure. So you have pressure that is basically in a logarithmic fashion. So as you go up, the distance between pressure levels is greater, so it's a logarithmic scale.
Yep.
Now the temperature, you can have the temperature being vertical like this, but we actually skew it to the side. And the reason why we do that is because when you launch a weather balloon and you're taking temperature and dew point measurements at the pressure levels, the temperature and dew point lines will actually run off to the left side. If you have everything straight, it will run off the left side really quick.
Just kind of goes right off the page. And It's like, well,
Exactly.
that's not really helpful because now we got to print a page that's 10 feet long just to get this
right.
line.
So when you get up to 18,000 feet, 500 millibars, 400 millibars, 24,000 feet, somewhere in there, the line would be so far to the left that, you're going to miss a lot of the jet stream stuff. So we skew the lines to go to the right at a diagonal, so that way it'll take the temperature and dew point profile and straighten them out. So we skew the temperature to make it go like that.
Yep.
So with that knowledge in place, the reason why it's called a nose is because it actually, when the temperature dew point gets plotted, it actually looks like a little nose to show that inversion layer.
Yep, it's kind of like the side of a face is your temperature profile.
There you go.
The more you know.
Aww.
A great example of where this freezing rain scenario happens often is where we live in central North Carolina. And that's because it's not cold in the south. So the probability of getting like the entire atmosphere to be freezing enough to have, snow in cloud, snow on ground is not really gonna happen. And you got the mountains and the topography and all that stuff. So often North Carolina is in a warm nose.
You got to have a very good situation, cold high pressure up over the northeast. You got to have a low that's far enough south, say over the Gulf Coast, and it's still off to the south of the North Carolina area, so that cold air can continue to pour down at the lower layers and establish itself before the precipitation comes in, yada yada yada. So you got a lot of that stuff so it's hard. The mountains will get it more because they're higher in elevation, where they're up closer to the colder air, but down in the valleys and down in the Piedmont area, it's hard to get winter precipitation because you just got the warm fetch coming in out of the Gulf, coming on off the Atlantic, and it just sets up for a warmer profile that's too thick.
Too warm in the south.
But there are occasions when it does happen.
Yep. Definitely no Denver or Minneapolis or Buffalo. But
Definitely not Buffalo.
So, in short, that is why you can have a temperature of, say, 29 degrees and it be raining, or 15 degrees and it be raining. And on the flip side, you can also have it be 37 degrees and snowing. All has to do with those Skew-T log P's and lines and this one, and noses and...
It all depends on that atmospheric profile.
Yep, so next time it's freezing outside and it's raining and your friends go, what is happening? It's the end of the world. You can be like, guys, it's because of a warm nose.
And if you want to follow us over on our other social media platforms, Instagram, Facebook, we'll pop them up right here, as well as our website.
Which will be linked down below.
That's right.
Until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And may your warm nose be where you want it on your Skew-T log P diagram.
Exactly. Gosh. Goodness. We are working professionalism.